Hello everyone. Today I'll be explaining you the lab session of embedded system design, and these are the course objectives. So this course will enable the students to understand applications of embedded system, and also they'll be able to understand some fundamentals of the ARM. These are the lab experiments that we'll be covering in our consecutive videos, and today I'll be explaining you the first and the third program to find the sum of first n integers as well as to find the factorial of a number. So this is to find the sum of first n integers. Here we have called this as ALP program in this embedded C. I'll explaining you the steps of this ALP program. Since this is our find the first 10 integers, so we are declaring 10 to our first register R1, and then to store the result we are also making utilization of R2 register, so it is initially 0. In order to add the integers, we are adding the first integer, that is 10, which is there in my R1, and also the R2 has 0, so 10 plus 0 will be added, and that exa value will be stored in your R2, and this one subs will decrement the R1 by 1 value. So R1 was 10, now it is decremented by 9. Then branch if not equivalent. So here what it will happen, if it is not equivalent, that means if it is not equivalent to 0, R1 is not equivalent to 0, then it should be in this loop only. So now R1 is decremented, so it is now 9. So 9 plus R2 is a new value what is being added, that will be there in my R2, so that 9 and 10 will be added, and the exa value of the resultant will be stored in my R2. The complete stepwise execution I will be explaining you in the software Keel Microvision 4. This is a third program to find the factorial of a number. So here what is happening is we are finding the factorial of 7. So the 7 is initialized to register R0, and then we are moving that 7 into R1, and then here R1 will be decremented by 1 value. Why? Because R0 is 7 and your R1 is decremented by 1 value, that means it will be 6, and compare that until your R1 is keep decrementing, and make sure your R1 reaches 1. Whenever your R1 reaches 1, then it should be branch to this, come out of the loop. So completely like I'll explaining you in the software. So after, since now in this it is not equivalent to 1, what will happen, your R1 will be 6 and your R0 will be 7. So 7 into 6 will be multiplied, and the resultant will be stored in my R2. Finally, I will move my R2 to R0. Why? Because it is factorial means 7 into 6 into 5 into 4 into 2 into 1, right? So now 7 into 6, the resultant should be multiplied with the 5 value. So that is the reason, since my R1 was decremented by 1, that means R1 was 7 and decremented to 6, and after the multiplication, now again it should decrement to 5. So 5 into the resultant value. So the complete explanation I will be doing you in your in the Keel Microvision software. So here is the Keel Microvision software. So go to the project. So what will happen is let me explain you the program here. So here already I have done all the steps to do the experiment. So here addition of I have added the C program as well as the .s as an ALP program. So after adding this we have to debug the program. So just save it and debug it. So I have 0 errors. Similarly my C, just save and debug it. So 0. So what you will do, start debugging. Directly if you run, you can get the final result of factorial of 7 in your R2 with the hexa value. But if you go with the stepwise execution, make sure your R0 is initialized to 7. So finally you can see the final resultant value R2 is 37. I'll just show you the stepwise execution. So here is my here R1 should be initialized to A. Initially R1 here it is A means it is 10 and R2 is 0. Next what will happen, R1 will move to sorry, here R1 is 10, R2 is, that means it is multiplied, your added addition is added, R2 and R1 is added and the resultant is in your R2. Decrement R1 by 1, so it is 9. So like that it's keep on decrementing and it will do the addition and the resultant will be stored in my R2. So the final hexa value, that means first in integers decimal value is 55 and the final hexa value is 37, which is stored in your R2.